So like you have this guy and he wrote 6 numbers, and you know 3 of the numbers are 44, 59, and 38. And we know that the sums of the 2 numbers on each of the 3 cards are equal, and the 3 numbers on the hidden sides are prime numbers, and we want to know what is the average of these prime numbers. So for this question, like the idea is like, let's say like the numbers on the other sides were like, let's call them like P, Q, and R, or let's call them like X, Y, and Z actually, because maybe we're more familiar with X, Y, and Z. So let's say on the other side, the 3 numbers are X, Y, and Z. So like, so we know that the sum of the numbers, the 2 numbers for each of the 3 cards is going to be the same. So like, then we would know that X plus 44 is equal to Y plus 59 is equal to Z plus 38. And we know that X, Y, and Z are all prime numbers, right? So we have that X plus 44 equals Y plus 59 equals Z plus 38. So the idea is like a lot of these like prime number questions, especially on the AMC 8, a lot of the times like questions involving prime numbers, like a lot of times you want to look at the number 2, like the number 2, because like 2 is a very special prime. And the reason 2 is special is because like it's the only even prime out there. Like out of the infinitely many primes out there, 2 is the only even prime. And a lot of the times for these prime questions involving prime numbers, it's it's like a very good idea to look at something called parity. So what parity means is like whether or not a number is even or odd. So I can say like, 44 has an even parity, 59 has an odd parity. It's just like a fancy word to say even or odd, basically. So basically the idea is, notice that like if Y was an odd number, right? Like if Y was an odd number, so like most prime numbers are odd except 2, which is even. So if Y was an odd prime number, then Y plus 59, we would get an even number, right? The sum of 2 odd numbers is equal to an even number. But if Y plus 59 is an even number, then that tells us that X and Z are both even numbers as well. But like, we can't have X and Z both be even, because if X and Z are both even, then we know X must equal Z must equal 2. They both must equal 2. But like, that's clearly not allowed, because the question, in the beginning of the question, they said Barry wrote 6 different numbers. So all 6 numbers have to be different. So you can't have like 2 variables equaling each other. So that tells us that Y cannot be odd. So if Y cannot be odd, that tells us that Y is even, right? So if Y is even and Y is prime, that means we know Y must equal 2. So then we get X plus 44 equals 2 plus 59 equals Z plus 38. So this is 61. So we can easily solve for X and Z now. So X is going to be 61 minus 44, which is 17. And Z is going to equal 61 minus 38, which is equal to 23. And we can easily verify that 2, 17, and 23 are all prime numbers, which is good. And if you did really want to double check, you can just plug it back in and it'll turn out to work. So we go back to the question and we want to know, what is the average of the 3 hidden prime numbers? So we found the 3 hidden prime numbers are 2, 17, and 23. So the average of these 3 numbers would be 2 plus 17 plus 23. Divide by 3, which is 42 over 3, which is equal to 14. And yeah, that would be choice B, and that'd be the answer.